All right, we're in the Helicopter Flying Handbook, Chapter 13. We're on page 6 of 10, Obstruction Detection. Obstructions having poor reflective surfaces, such as wires and small tree limbs, are difficult to detect. The best way to locate wires is by looking for the support structures. However, pilots should review the most current hazard maps with known wire locations before night flights. Aircraft lighting. In order to see other aircraft more clearly, regulations require that all aircraft operating during the night hours have special lights and equipment. The requirements for operating at night are found in Title 14 of the Code of Federal Regulations, 14 CFR, Part 91. In addition to aircraft lighting, the regulations also provide a definition of night flight in accordance with 14 CFR, Part 91. Currency requirements, fuel reserves, and necessary electrical systems. Position lights enable the pilot to locate another aircraft as well as help determine its direction of flight. The approved aircraft light for night operations are a green light on the right cabin side of the wingtip and a red light on the left side cabin or wingtip and a white position light on the tail. In addition, flashing aviation red or white anti-collision lights are required for night flights. These flashing lights can be in a number of locations but are mostly found on the top and bottom of the cabins. Figure 13.7 shows an example of aircraft lighting. By interpreting the position of lights on other aircraft, the pilot in aircraft 3 can determine whether the aircraft is flying in the opposite direction or in a collision course. If a red position light is seen to the right of the green light, such as shown in aircraft, it is flying towards aircraft 3. A pilot should watch this aircraft closely and be ready to change course. So if you see red on your right side, that's not good, they're coming towards you. If you see red on your left, they're going with you. Because red's on your left, green's on your right. So if red's on the left, they're going with you, same directions. Red's kind of on your right side over there. They're probably coming towards you. All right. So, on the other hand, let's see. Aircraft 2, on the other hand, is flying away from aircraft 3 as indicated by the white position light. Visual illusions. Visual illusions. Illusions give false impressions or misconceptions of actual conditions. Therefore, pilots must understand the type of illusions that can occur in resulting disorientation. Although the visual system is the most reliable of the senses, some illusions can result from misinterpreting what is seen. What is perceived is not always accurate. Even with the references outside the cockpit and the display instruments inside, pilots must be on guard to interpret information correctly. Relative motion illusion. Relative motion is falsely perceived self-motion in relation to motion of another object. The most common example is as follows. An individual in a car is stopped at a traffic light and another car pulls alongside. The individual that was stopped at the light perceives the forward motion of the second car as his or her own motion rearward. This result is the individual applying more pressure to the brakes unnecessarily. This illusion can be encountered during flight in situations such as formation flight, hover taxi, or hovering over water or tall grass. Confusion with ground lights. Confusion with ground lights occurs when the pilot mistakes ground lights for stars. Pilots can place the helicopter in an extremely dangerous flight attitude if he or she aligns it with the wrong lights. In figure 13-8, a helicopter is aligned with road and not with the horizon. Isolated ground lights can appear as stars and could lead to the illusion that the helicopter is in a nose-high altitude. When no stars are visible because of overcast conditions, unlighted areas of the terrain can blend with the dark overcast to create illusion that the unlighted terrain is part of the sky, figure 13-8b. In this illusion, the shoreline is mistaken for the horizon. In an attempt to correct for the apparent nose-high altitude, a pilot may lower the collective and attempt to fly beneath the shore. This illusion can be avoided by referencing the flight instruments and establishing a true horizon and attitude. Reverse perspective illusion. At night, an aircraft or helicopter may appear to be moving away when it is actually approaching. If the pilot of each aircraft has the same assumption and the rate of closure is significant, by the time each pilot realizes his or her own error and assumption, it may be too late to avoid a mishap. This illusion is called reversible perspective and is often experienced when the pilot observes another aircraft or or helicopter flying parallel course. To determine the direction of flight, the pilot should observe the other aircraft's position lights. Remember the following: red on right returning. That is, if an aircraft is seen with a red position light on the right and the green position light on the left, the observed aircraft is traveling in the opposite direction. Yes. Flicker vertigo. Flicker vertigo is technically not an illusion. However, as most people are aware from personal experience, viewing a flickering light can be both distracting and annoying. Flicker vertigo may be created by helicopter rotor blades or airplane propellers interrupting direct sunlight at a rate of 4 to 20 cycles per second. Flashing anti-collision strobe lights, especially when the aircraft is in the clouds, can also produce this effect. One should be aware that photic stimuli in certain frequencies could produce seizures in those rare individuals who are susceptible to flicker-induced epilepsy. All right, we'll hold off there. Just finished off there on page 7 of 10. That was aircraft lighting, pretty much. Obstruction, detection, aircraft lighting, visual illusions, relative illusions, illusions, and finishing off with flicker vertigo, page 7 of 10. See ya.